So we are going to solve another question which states that a student and his friend, while experimenting for a projectile motion, the stopwatch takes some approximate readings. As one throws a stone in air at some angle, other observes that after 2 seconds it is moving at an angle of 30 degrees to the horizontal, and after 1 second it is traveling horizontally. Determine the magnitude and direction of initial velocity of the stone. So first of all, let's draw the diagram. It states that a stone is thrown with initial velocity, let's assume at u, and angle of projection is given as theta. Let us assume it is theta. So this point is A. So it is given that after 2 seconds it is that a stone, let's suppose this is the position after 2 seconds, and at this point it is having a velocity v and it is making an angle of 30 degree with the horizontal, and after traveling more for 1 second, suppose it reaches point C, and here it after 1 second it gives that it has only the traveling horizontally. It means it has only horizontal component. So at this point this will be nothing but the point where the projectile is at its maximum height. So we are given that TAB, the time between A and B, is 2 seconds. TBC is equal to 1 second, and we are supposed to find out what will be the initial velocity u and what will be the theta. These two things we have to find out. We know the formula that the time of flight of the projectile, if it is represented by capital T, is given as 2u sine of theta divided by g. And at the maximum height, the time of flight from A to C will be equal to 1/2 of total time of flight. So we can write this as 1/2 of 2u sine theta divided by g. 2 cancel out with 2, so we get u sine theta by g. So in this case we are going to take g as 10 meter per second square. So we can find out what it will be TAC. TAC will be equal to TBC plus TAB, that is equal to 1 plus 2, that is equal to 3 seconds. So substituting value of T as 3 seconds, we get u sine of theta. Value of g is as 10, so this will be equal to 30 seconds. Let this be question number 1. So let's discuss motion in x direction first of all. So we also know that the horizontal component of the velocity of the projectile remains same through entire the journey. So in case if the horizontal component at point A is given as u cos of theta, and at point B is given as v cos of 30 degree, then we can say that u cos of theta is equal to v cos of 30 degree. And in y direction, between point A and B, we can use formula v is equal to u plus at. This is point between A to B. So in y direction, so we write this as component y. So in y direction, the velocity will be equal to v sine of 30 is equal to, for initial velocity it will be u sine of theta, this will be minus g, and multiply by time 2 seconds. We already know the value of sine of theta, so that will be equal to 1 by 2. This will be equal to u sine theta, we already know is given by 30, so this will be 30, g is 10, this will be 20 is equal to 10. So we get a velocity component at point B as 20 meter per second. So we are going to use, let this be question number 2. So we can write that u cos of theta is equal to v is 20 multiplied by cos of 30 degree. So we get this as root 3 by 2. So u cos of theta will be equal to 10 root 3. Let this be equation number 3. So we are going to square equation number 1, square equation number 3 and add them. So we get u square sin square theta plus u square cos square theta is equal to 30 square plus 10 root 3 whole square. So if we take u square common from here, so we are left with sin square theta plus cos square theta. This is equal to, this will be 900 plus this will be 300. Ultimately this will be coming as 1200. So this is 1. So u square will equal to 1200 and the value of u will be coming as 20 root 3. So we already find out what is the value of u. And in the second part, what we are going to do, we are going to divide first by equation number 1 divided by equation number 3. So we get sine of u sine of theta divided by u cos of theta is equal to 30 divided by 10 root 3. U goes with this, so this comes as 10 of theta is equal to 3 root 3. So if we rationalize it, we are going to be left with only root 3. It means tangent of theta is equal to root 3 and theta is equal to 60 degree.